Hey folks, welcome to another Triple T Thursday. For those just joining us, that's tools, tips, and talk, where we'll discuss info for the knife maker. In today's episode, we're going to continue our Balisong knife build. In this episode, we're going to heat treat and grind out the blade, and we're going to start on the handles and drill the pivots and the stop pins in the handle. And the big thing is, we're going to try to mill some titanium, which I've never done. So we're back at this Balisong knife. I got the blade here, and that's what we're going to do first. Cut this out, and then use the optical center punch and drill our pivot holes. Then we're going to start to work on the handles. I do need to heat treat this pretty soon because we're going to need to know final thickness here in order to know the size of the slots. So let's get to this. Now we're going to use the optical center punch. This has got a little magnifier in it, which you position, and then you press this down, pull that out, and put the punch in to exactly get where these need to be punched. So let's do it. So there's our 1/4 inch pivot holes. We started those with a 1/16 inch drill and then moved up to a 15/64, which is actually just less than a 1/4 inch because I reamed these with a 1/4 inch reamer. So now the bushings should just slide in there. Look at that. They just slide in, and they're just held there with friction, which is perfect. Nice. All right, now I'm actually going to harden this blade because everything else we need to do is with it at its final thickness. So let's go get it hardened. Well, the blade is in the oven getting heat treated. Let's talk about the handles. So here's the handle that the one I'm copying off of. We're going to take some measurements, and we need to reduce this titanium down to kind of a rectangular form to match these. These do taper slightly, but I'm going to do the taper after. The first thing is just to machine this down to a rectangle. Machining titanium is a little different, and this will be my first time doing it, so I'm expecting some issues. Let's go try it. Even cutting titanium with an abrasive disc takes forever. I went through a disc and a half just to make these 2 cuts through 3/4 inch stock. Remember folks, if you guys need anything for knife making, whether it's steel, abrasives, equipment, you name it, go check out Maritime Knife Supply. They got everything you need and they'll set you up. Before we talk about milling titanium, I want to talk about some milling basics. So in case you don't know the differences of the different kinds of milling. So normally when we're milling, okay, we're usually trying to do what's called conventional milling, which means the mill, which is normally turning clockwise, I'm using this big end mill as an example, we are scooping think of it like this. We're doing this and we're scooping out the material. Okay, this is called conventional milling. Okay, the other way, so that means the cutter is going this way, okay, and kind of scooping out from the bottom. The other way is what's called climb milling, when we're going this way, and that means that the cutter actually lands and has to dig into it like this. And it's kind of like, it's almost like it's climbing up on it, and this is called climb milling. Generally, climb milling, bad. Conventional milling, good. Climb milling, because there's so much contact every time the cutter moves, it's actually moving a lot of material. Whereas if it's going this way, it's just scooping a little bit of the material. So if you're using conventional milling, that's normally what you do for heavy passes, and climb milling is for your finish passes. But on titanium, the major issue is heat and heat buildup. And conventional milling actually builds up more heat because the cutter contacts the piece here. Even though it's only cutting a little bit, there's a lot of friction, and it has to actually just cut a little bit of it. So there's much more friction in conventional milling. So you actually, opposed to normal thinking, on titanium, you actually want to do climb milling, and that's what we're going to do. So here I'm taking an 1/8 of an inch off each side of this cylinder to make a 1/2 inch bar. Here's a good shot of it climb milling, meaning that the clockwise rotation is going towards the cutting. It's also important to note that you mill titanium at about twice the RPMs you cut steel. I've milled both sides now. Now we're milling the top, and you'll notice I actually forgot and set this up with conventional milling, and I couldn't understand why it was chattering until I realized what I did. So I've got the two handles milled out, at least 3 sides, because there's going to be a taper that I still need to mill in. But in case you're curious, this is all the titanium that came off. It's quite a bit. There's a whole bunch back there still. Okay, so now that these are all milled, I want to do the pivot and the stop pin holes. Now I have nice reference surfaces, which is why I didn't do the taper yet, because I want to have this square so I can put it in the mill. And I took some sizes so I know where this hole is going to be in relation to these two sides and where this hole is going to be. So I can do everything on the mill. Our first operation is to find the edge of this part, and we want to do that precisely, so we're using this edge finding tool, and as soon as it kicks out, we know we're at the edge of the part. Now I've used my DRO to spot this hole. I'm drilling it with a 1/16 inch drill bit, then I'll move up to a number 17, and finally I'll ream it with a 3/16 reamer. So there are our parts so far. I've got the knife heat treated and tempered. We have our pivot holes drilled, and we've got our handles with the pivot holes drilled and the stop pins. That's actually going to be all for today. I need to do some more finish work. In fact, I need to completely finish the knife so that I know its thickness, and then I can do the slots here. So I'm out of time for today, but that's what we're going to start with next week. Thanks, folks. See you on the next one.